Hey, welcome back. In this part of the series, we are going to discover a new primitive data type added in ECMAScript 2015, which is symbols. As you know, there are 5 primitive data types in JavaScript, which are string, number, big int, boolean, and undefined, until they introduced symbols in ES6. So, what exactly is a symbol? Well, symbols were created to serve as keys for object properties in a way that they protect their values by making each property key unique so their values don't get overwritten accidentally, making the object properties kind of private, or let's just say not easily discovered. In addition to that, symbols are utilized to customize JavaScript built-in functions in order to make them work with the different objects we create using what is called well-known symbols. Before we start, I like to mention that in some cases we'll be using the brackets notation to access an object property. In brackets notation, we use the object name followed by the key as a string, wrapped by a couple of brackets to get the value of that property. We can also add a new property to an object by using the same syntax. Moreover, we can use a variable that contains a string between the brackets instead of using a string directly. Back to the main topic, to create a symbol we need to declare a variable, then call the symbol function with capital S. Now the simp1 variable contains a unique value, so if we create a second variable simp2 and compare both variables, you see that the result of the comparison is false. Furthermore, we can add a string as an argument to the symbol function, which only purpose is to serve as a description. Again, this will not affect the value of the symbol, it is just there for debugging purposes. So, if we add the same description of the first symbol to the second one, you see that the result of the comparison is still false. With symbols introduced, we can use a symbol with the brackets notation to add a property to an object instead of a string. Now, here is an example where a symbol could be a good choice to use as a property key. Imagine we are working on an application that makes a request to a certain API, which in result returns an object that has hundreds of properties. So, to add a new property to that object, we'll have to loop through it before adding the new property to make sure that the object doesn't contain another property that has the same key as the one we wish to add. That said, now with symbols we can skip looping through the object and just use a symbol as the key of the property and add it to the object without worrying about overwriting an existing property. Earlier we've talked about symbols making a property sort of hidden or hard to access, and that's actually manifested in symbols being not enumerable, or let's just say cannot be exposed during an iteration. Let's say we have an application that sends an object to an API, then that API in its turn sends it to another application. Now, as the receiving application, to see the properties of that object, we can iterate through it using a for-in loop. Or we can use the object getOnPropertyNames to get an array containing the keys of that object, and then we can use the brackets notation we've seen earlier to get the values. That being said, things are different when the object has symbols, so let's add one and see what we will get when we try to expose the object properties. As you can see, both methods have successfully displayed the regular properties, but not the symbol. That's what it's meant to make an object property private, because we don't have the variable containing the symbol that was used as key for the property, since it was created on the sending part of the object, and thus isn't accessible on the receiving part. That said, symbols are still not 100% private because we still can expose them, and that's why I said they are just not easy to access earlier. To do that, we need to use the object getOnPropertySymbols, which returns an array containing the object's symbols, and then again we can change their values using the brackets notation. Say for some reason we want to assign a symbol to two different variables. To do that, we need to use the symbol form method instead of symbol, and this time the string argument serves an ID of that symbol. I'll get into that in a second. Let's create another variable with a different ID. Now, the comparison of the two variables returns false. You have probably guessed it right. That said, now let's make the two symbols have the same ID. As you can see, the result of the comparison is true, and here's why. When we use the form method to create a symbol, we are actually checking a registry. That registry has all the symbols we have created within our code with their IDs. So, if the ID of the symbol we are trying to create exists in that registry, the variable will be filled with the existing symbol. If it doesn't exist, then a new symbol with that ID will be created. So here, the first line creates a symbol with the ID of symbol 1. Then, at the second line, we are assigning that symbol to the sim2 variable. We can also check if a symbol exists in the registry without creating it if it doesn't exist by calling the symbol keyForm method. Last but not the least, well-known symbols. To get a better understanding of what they are and why we need them, let's start by creating a regular boring hello world string. Now, say we want to call the search method on the string to see if it contains a certain character. As you can see, the search method returns the index of the searched for character or string within the original one. The kind of strange thing here is if we look at the MDN website or any other website talking about this method, you'll notice that they say that the search method actually takes a regular expression as an argument, not a string. If you are not familiar with regular expressions, a regular expression is another data type. It's a sequence of characters that forms a search pattern. Here's an example. Say we want to search for the space character within the string we created earlier. To refer to the space character, we can use the following regular expression. So the question here, why did a method that is supposed to accept only regular expressions work when we passed a string to it? Well, the answer is simple. When we call search with a string as an argument, the search method internally converts it to a regular expression, then it performs the search. Now, knowing that, JavaScript developers wanted to do the same thing with custom objects. In other words, they wanted to get access to the body of the built-in search function so they can imitate the same behavior it does with strings. That means that they wanted to be able to make the search method accept custom objects and return a result based on the modification they made to it. However, prior to ES6 that wasn't possible, and that's where well-known symbols come in. I know this is a bit confusing, but once you see the example you'll get the idea, so let's create an object. Now, to make this object acceptable as an argument for the search method, we must use the following syntax. Symbol.search is a well-known symbol that is responsible for the interaction between an object and the search method. Value here refers to the string from which we called the search method. With that done, now every time we call the search method on this object, it will return the string some value. Let's make this example a bit more interesting. So, say we want the search method to return a certain value based on the value of one of the object's properties. So here, if the myStr property has the same value of str, the returned value will be this object contains the string, and value here again refers to the value stored in the str variable, else it will return the string. This object doesn't contain the string hello world. And this is it for this part of the series, so make sure to subscribe and I will see you in the next one.